So, light is a form of energy which gives visual sensation. And more scientifically, light is a kind of electromagnetic wave, like ultraviolet, infrared, etc. What are these electromagnetic waves? Well, it is the discussion of some higher classes, but in easy words, I can say like there are so many waves which travel through the space, which are just propagating uh, here and there on Earth. So, among these waves, light has the ability to uh, give us visual sensation. In few insects and animals, it is scientifically observed that they give responses to ultraviolet or infrared rays. So they are adapted to those radiations also. But human beings, we are just limited to that visible range, which is divided into 7 parts. I think you know this acronym. And that is why the rays before this violet is called ultraviolet, which we can't see, but which can do tanning on our skin. And infrared, which comes after red. Infrared means heat. I mean, when near a hot body we receive warmth, that warmth is actually infrared radiations. You might not be aware about that in our remote control set, it also depends upon infrared radiation. So you people can argue that it is not warm enough. So that infrared is very less in amount. That is why. Now this is something all of us are aware about. Light propagates in a straight. It is looking a little bit bad. In a straight line. And it is called rectilinear propagation of light. That is rectilinear propagation of light. Propagation means what we call move. Actually, in case of light, we can use the term travel or move, but the more scientific term is propagate. Light propagates. All right, so maybe sometime I will casually use the term light travels, but more scientific is propagate. Let's move to next thing. Now, actually, student, due to some limitation, I'm not able to perform these activities. But in a separate video, I will try to perform these activities. Anyway, so you can perform. Take 3 cards and a big one, big cards, approximately this much amount of size, and make a tiny hole. And take cards, okay? Don't go for paper. Actually, paper will not block the light. So, take a cardboard. So, make holes at the center of each of the card, and then illuminate first card with the help of a torch, not so bright torch. All right, so you will observe that if these 3 holes are aligned, so we can observe light coming out from the third card. But if we somehow slightly dislocate this card in the middle, then we will not receive any light from the third card. In other activity, you can take a pipe. A rubber pipe will be convenient, and from here you can glow the torch, a less bright torch, and from here you can observe. Don't look directly to light, just observe from here. This is you. Okay, so you will be able to watch this light is coming out, a glow from this end. But if bend this pipe, then you will not be able to see light coming out from this end. It is because light travels in a straight line. All right, so next, light originates from a luminous object. What is a luminous object? It means the object which has its own light and propagates in a straight line until an obstruction comes in its path. So what happens afterward? Now, this is a luminous object. Now, what are luminous objects? So you can comment me for that. Okay, so from this luminous object, maybe a bulb or a lamp. Is moon a luminous object? So you have to answer about it anyway. So now there is an obstruction. Again, another example, another obstruction. It will be better if I will incident the light at an angle. All right, so three things can happen. First, it can transmit into that medium. We can say if it is transparent, that is, light can travel through it. Translucent, light can partially pass through it. So light can pass through it. That is called refraction. This is the first medium, let us suppose air. This is another medium, let us suppose glass. So then light ray deviates. That is called refraction. Here we will not say that now there is no more that rectilinear propagation. Actually, now this surface has came. So at this surface, direction has deviated, but still afterward it will travel in a straight line. So light travel in a straight line till an obstacle comes, till some obstruction comes. So if it is transparent, so it will get refracted. If it is translucent, so it will get refracted and some part of it. So I'm considering this much amount of light and fewer part will get absorbed. Rest of the part may or may not be get transmitted through that. So it is absorption. Third thing, okay, due to this absorption, if you place a transparent glass sheet in front of you, you can easily recognize that something is in front of you. So glass manufacturers have worked very hard to make very clear glass. So maybe Asahi is a company. I'm not promoting any company, but I hope you have seen their advertisements. So they say that their glass is so transparent, so that it looks that there is nothing, no glass sheet is there. And because they have minimized this absorption part. So third thing, all right, now third thing, the most important part on which this entire lecture is based upon, light get incident on this surface, and after striking the surface, it will get reflected into same medium. Let us suppose this is air. So after falling onto this surface, it will get back to air. So this will be called reflection. Now what is reflection? All right, so before I read this definition, just see this marker cap. It get reflected. After hitting, it also get reflected. So when light falls on a reflecting surface, well, all the surfaces, all the objects what we see around us are reflecting objects. If they were not, we could not able to see them. So every surface is a reflecting surface, which we are able to see. So when light falls on a reflecting surface, we can reduce it to a surface. Okay, it bounces back into same medium by following the laws of reflection, because otherwise this statement says that it can go in any manner, but no, there are some rules for that. This phenomena is called reflection of light. Let's move close to the nature. So the things which we see around us, it is just because of reflection. Anything which we are able to see is because of reflection. Light strikes that surface and reflects back to us. Then we are able to see that. Yes, it is due to reflection of light. Now, there is air in between the camera and this board. So actually, air is not reflecting the light. Otherwise, you could imagine what would be the nature of the world around us. Clear and still water, clear glass. They also not reflect the light in larger amount, so that we can't see them. I mean, that is why they looks like they are invisible. However, we can recognize water, clear water, and clear glass also. So there are two laws of reflection. First, I would like to tell you second law of reflection. Actually, there is no priority, but most of the time, which I am saying right now is considered as second law of reflection. So I'm writing it first, but I will mark it second. So first law says angle of incidence is equal to angle of reflection, angle I equal to angle R. Now, where is that angle I and where is that angle R? So let us suppose this is a reflecting surface. So this is incident ray. I'm not writing entire name. Inci ray. Vinci ray. And next, first I will mark a perpendicular line with respect to this plane surface. So this is the perpendicular with respect to this plane surface. And now here is a terminology of a bit higher classes, like in terms of line, because it is looking like a line. So in terms of a line, if there is a perpendicular line, we call it a line which is at an angle 90 degree, we call it perpendicular. But in case of a surface, like this is a surface, and this marker is making a 90 degree with the surface, then this marker will be called normal. So we can say normal means perpendicular, which is on a plane surface. This is a plane surface, and this is its perpendicular. So that perpendicular is called normal. So now I hope it is clear to you that this is the line, and if any other line is making 90 degree onto it, it will be called perpendicular. And in the case of a surface, if this line makes 90 degree with that surface, then this line will be called normal. All right, so now this is incident ray and this is normal. Few students and few people call it normal ray. It is not a ray, it is just a line which is normal. So this is reflected ray. Now this angle which is measured from the normal is called angle of incidence, and this angle which is measured from normal and made by this reflected ray is called angle of reflection. So remember this thing, we don't consider this side angle, means angle from the surface. We take angle from the normal. So remember this thing, angle of incidence is equal to angle of reflection. So if in a case there is an incident ray making an angle 35 degree with the normal, then angle of reflection will also be 35 degree. And if someone asks you to complete this diagram, and such kind of question comes in the exam also, complete the reflected ray, and they have given some angle 40 degree here. So what you need to do, just copy the diagram and draw a 40 degree here also and mark it away going. So, all right, there is a question in my mind. Let us suppose in a question, this angle between incident and reflected ray is 90 degree. So what will be the angle of incidence and what will be the angle of reflection? So we know, if you want to solve it by yourself, so pause the video and solve it. All right, if you have solved, now I'm solving it. We know that I equal to R. I'm not putting this angle sign just to avoid those complications. So we have given the sum of both of them. So I'm writing them X. So I plus R is given there 90 degree. It means I is X, R is X, means 2X is 90 degree. And it means X is equal to 45 degree. And it means angle of incidence, it means angle of reflection. Okay, another question can also arise here. The question is, in this part, the question is, complete the diagram. Second thing, find angle of incidence and angle of reflection also. So how will you do that? This is I. So you will write I equal to, see, this entire angle is 90 degree. This is normal. Normal is at an angle 90 degree with the surface. So I will be the complement of this 20. That is 90 minus 20. Simple mathematics, 70 degree. So also R is 70 degree. Now you will write here 70 degree and you will measure it and draw another 70 degree here. It is not looking like 70 degree, but it is a rough diagram. So, all right. Now another question. Is it possible to have angle of incidence 0 degree? So what does it mean? I have said that angle of incidence 0 degree. And in another case, I am saying that ray incident normal to a surface. reflecting, of course. Now what will happen? So in first case, I equal to 0, how we are going to draw that? So first we have to draw a normal. Now 0 angle means angle is measured from here. 0 angle means nothing. So what will be the angle of reflection? It will also be 0. How can we show that? That's all. So many students can think that this angle should be 90 degree, but no, students, angle is always measured with this normal. And if there is a line and another line is over it, so what is the angle between them? 0 degree. Now here, I hope you get the answer. A ray incident normal to the surface. So first we will draw a normal also. It will coincide with the ray. This will be the reflected ray. So here also I equal to 0, R equal to 0. These questions are tricky questions. Remember these. Now first law. So here it is, incident ray, reflected ray and normal to the surface all lie in same plane. Okay, so these three things, incident ray, reflected ray and normal to the plane, they must be in same plane. Okay, this part actually in your books I think till here it is, but this sentence fulfills the need, further need, but before that I will explain this part. When I will explain this part, after that I can be explain this part also. So first just focus on this part only, which is essential part in your books also. Incident ray, reflected ray and normal to the plane all lie in same plane. What does it mean? This is normal, incident ray. Now student, there is a confusion about what does it meant by plane. So I will explain it. Now let us suppose this cell phone is a mirror. Then there is a normal to the plane, incident ray, reflected ray. All lie in the same plane. Which plane they are talking about? Is this that plane? No. Well, actually, they are talking about these three lines. They should be on same plane. Now, just ignore that background drawing. Let us suppose this is that reflecting surface, this reflecting surface, and this is incident ray, this is reflected ray, and this is normal to the plane. Here we have incident ray, reflected ray, and normal to the plane. So they will lie like this. Like this. So what is the meaning of they'll all lie in the same plane? So all of these three will lie on same plane. This is a plane surface, so they all lie in this same plane. Means they want to say, they are not talking about this reflecting surface plane, they are talking about these three will lie in a plane. So what is the importance of this? Its importance is, if ray is incident along this direction, it will get reflected, and this is normal to the plane, and this reflected ray, it will not be bent like that way or this way, it will be in this plane, so that we can pass a surface through it. It should be like this. Okay, like this, so that we can pass a plane through all these three. Now the other part, that this incident ray and this reflected ray, they must be on opposite sides of this normal. Next is types of reflection. So there are two types of reflections. One is regular reflection and other one is irregular reflection or diffused reflection. All right, so what is regular reflection? It is the kind of reflection in which the intensity of reflected light does not change, or we can say in which light get reflected in well-mannered order. Irregular or diffuse reflection. So it is a kind of reflection which is not in a well-mannered order, or in which intensity of reflected light changes. So you can see intensity of incident light, it is as it was incidenting, so also it is reflecting. But in diffused reflection, its intensity will get changed. So where do this regular reflection and where do this irregular reflection occurs? So first thing, if a surface is smooth enough, then light goes regular reflection, undergoes in a regular reflection. And if it is rough, then light undergoes an irregular reflection. It is rough. So most of the time you can see when like your floor of your home, generally you can't see your face into it, but when it is mopped, at that time it has a thin layer of water over it, then it become little bit smoother, then you are able to see your face or reflection of other objects on that surface. But that does not happen in ordinary case. All right. And in the same way, new utensils, new ornaments, they have a very good shine, but as the time goes, as the time passes, so they lose their glare because their surface becomes irregular, rough. There is a question, what about laws of reflection? Is it followed by regular this smooth surface only? No, it is also followed by this irregular surface. But see, if we see this irregular surface through microscope, it will look like this. Not the hills, but some irregularity I want to show. So if light ray, incident light ray hits this part, so on this surface, only this small part, we will take it as a plane surface. We will draw normal to it. This is the reflected light. Next, let us suppose it is incident on this point. So almost plane at this point. This is normal. It has gone there. Next, if it has been incident on, I'm doing a trick. Okay. Now, if it is incidenting on this, now see. So it will go like this. So there are different directions of reflected ray, but each surface where it is striking. On the other hand, if it is the case of regular reflection, so at each point, laws of reflection are applicable for both regular rough surfaces and smooth surfaces, because at the point of incident, there that law holds. Next is mirror. Mirror. So a reflecting surface, a smooth reflecting surface through which light undergoes maximum regular reflection is called a mirror. First thing, it must be smooth, it must be reflecting, and the reflection must be maximum regular reflection. So in our common life, when we talk about mirror, a glass piece comes in our mind, but that's not true. What happens, there is a glass piece, and on its backside there is a thin lining of silver or tin, and then nickel, chromium, and aluminum also, depending upon the quality. So best quality is obtained by silver coating. So this is a thin silver coating, and then it is coated with a paint layer. Now we have to protect this silver lining or tin lining or whatever the metals I have said. So from this side, it is prevented by this glass surface. From the rear side, it is prevented by this paint. So you might have observed that when mirror gets older, we see some spots into it. It is because that paint gets damaged. All right, so but here we are not going to draw mirror in this form. We will draw mirror in this form. This is the reflecting surface and this is its coating. Next is image formation by the mirror. So first we will see that how we can draw the image diagram of a dot. We will call it O, object O. So in order to draw image formation diagram of a point object, This is for the point object. So in order to draw a ray diagram, we must require at least two rays. So will become a bit tricky, and we'll draw a line that is at a zero angle of incidence. We have discussed it earlier, so it will get reflected along same direction. So if we are observing it, it appears that this ray is coming from inside the mirror along this line. So next, let us suppose, actually this object is not emitting these rays. Actually, from some other sources, the rays have been incident on this surface, and afterward it is reflecting those surfaces, and we are observing reflection, the light which have been reflected by the mirror. So here we will once again apply law of reflection. It will get reflected, and if we, because our if we observe this, it will be appeared like it is coming from along this direction. So here we will find I, that is image. This is all about point object, but what if we have some linear object? Linear object means a line. So let us suppose this is that linear object. So now, in order to become tricky, first I will change the orientation. So in case of extended objects, first step, draw a perpendicular line, perpendicular ray, which is actually at angle of incidence 0. Other, draw this way, it will get reflected along this direction. Now move backward, and both of these will intersect somewhere here. So here we will get this arrowhead image. Next, another ray. All right, so it is very convenient to draw a perpendicular line. That is normal ray. Now it will get reflected. Produce it here. Oh, sorry, dotted. Here we will observe tail of this arrow. So this is how we can draw the image formation for extended object or linear object. So these are the methods by which we can find the image. Now next, number of it is looking like number of images formed by inclined mirrors. So it is not a new thing for you people. You people might have noticed this. Actually, it is not focusing it anymore because of so much glare there. But if you will keep two mirrors in front of each other, there will be so many images you can see. So first thing, you must know what is the angle between the mirrors. So step 1, we can calculate it, and then later on you can do this activity, take two mirrors and incline them at different angles and see if this result, whatever I'm writing here, is matched with it or not. Step 1, calculate angle between mirrors, two mirrors, and we will call it A for angle. Step 2, find n, which is equal to 360 by A. Now follow this algorithm. Whether n is even, if n is even, then number of images will be n minus 1. And if n is odd, then again there are two conditions. First condition, whether object is placed symmetrically. Oh, I'm writing in short, otherwise it is going too far. Or object is placed asymmetrically. What is the meaning of symmetrical, asymmetrical? Let us suppose these are two mirrors inclined to each other. This is their angle bisector line. So if object is placed on this line, see, with n even, we don't require any other symmetry or dissymmetry, no. But for odd, if it is on the line of angle bisector, then number of images n minus 1. But if it is asymmetric, that is placed here or here, not on the bisector, then number of images are n. So that's all from my side. Uh, there are few topics which about light which I have skipped here, but I will cover them in next video. So keep on watching me, I mean my channel, and the nature, and enjoy reflection.